what are we simulating here? Taking a driving test, right? We're simulating taking a driving test. My handwriting gets really bad once I start using the pad. Okay, so you're about to take a road test for your driver's license. You hear that only 34% of candidates pass the first time. Okay, so 34% is the passage rate the first time they take it. But the percentage rises to 72% on subsequent retests. Estimate the average number of tests drivers take in order to get a license. Okay, so we have to simulate two different things. The first test, right? The numbers are going to be different for the first time they take it, and then any test after that, right? So we're going to, for first test, we're going to let 0 to 3 be 3, right? Be pass. 34 to 99, be fail. Okay. And then for second and anything greater, we have 0 to 71 because it's a 72% chance of passing, be pass, and 72 to 99, be fail. Okay. Now we could use the calculator, random digit table. On this, it's easier for me to show a random digit table because I can't display the calculator at the same time. So we're going to use a random digit table, 2 digits at a time. And we're going to record number of tests till we pass. One of those things you just keep taking until you actually finally get it, right? So for our random variable, our response variable is that number of tests. So for the first one, 62. On the first test, is that a pass or a fail? That's a fail. And 49 is the second test, which is a pass. So our first trial is 2. It took 2 tests to pass. Okay. Our second trial is 09, which is a pass. So trial 2 is 1. Okay. Okay, so my next one is 92, which is a fail, and the next number is 15, which is a pass, so that took 2 tests. Okay, so it wanted you to do this 20 times. 09 was a pass, so that was only 1 test. Yes, we're going to count how many times we have to take the test till we pass. Okay. So the next one is 84, which is a fail. 98, which is a fail. 72, we're in the second or more test, right? 87, right? At this point, your parents might just be like, maybe we should be using the bus. And 59 is a pass, so that took 5 attempts. Okay. Next trial, the next number is a 19, right? We're back to 0 to 33, meaning pass. So 19 is a pass, right? So it took 1. And the next one is 17. That's also a pass, so that's 1. Okay, see how I'm marking it up? I'm putting a vertical line where my trial ends, so that if I were grading your quiz, I can easily see exactly what you were doing and the numbers you were looking at. Okay, you need to make sure that I can see which numbers you used on this table, right? If there's no markings on it, how do I know if you did it right or wrong? So the next one is 71, which is a fail, because that's the first time, right? And the next number is 47, which is a pass. And that's 2. The next one is a 33, which is a pass, so that's 1. And so on, right? Next is 24, that's a pass, that's 1. 55 is a fail. 02 is a pass. So that time it took 2. Okay, yes.
Okay. So for the 47, okay, wait. So when you did the 71 to the 47, the 71 was a fail.
Right. Because we're looking at these numbers for the first number.
Okay.
So 71 is a fail in here.
And then after the first number, no matter
47. Now we're looking between 0 to 71 to be a pass.
and that's like you look at that until you pass.
Right. I look at this until we pass.
After the first one.
Yes.
You failed the first one.
Correct.
Okay.
Because if you pass the first one, you're not going to take it again. Nobody wants to go through that more than once in their lifetime unless they have to. Complete honesty, I failed my first driver's test. They failed me for going too slow. So, yeah, too slow. On my birthday, on my 16th birthday. It was not. Anyways.
On your birthday?
Yeah.
What's the probability of that happening?
I don't know, but it sucked. Okay, so I've done 10. You were supposed to do 20, but for time's sake, I'm going to stop here and find the average. 2, 4, 6, 8, 10, 12, 18. Divided by 10, 1.8. Yes?
Is that what you want us to put on the test, like 1.8 or just 2 tests?
1.8. Yeah. Keep it the decimal because it's an average. Right? So based on my simulation, I would expect it to take an average of 1.8 tests or attempts to get a driver's license. To get a driver's license. Okay, based on my simulation, just based on this, right? That's not the DMV's actual number, it's just my data based on what I've been given. And so overall, if we took all the people that took driver's tests at this place, this particular DMV, right, because we know some of them are harder than others, right, that the average would be about 1.8 tests, okay? And it doesn't have to be a whole number, because it's an average of everybody that took the test, okay? Yes? Any questions about that problem? To attract shoppers, a supermarket runs a weekly contest that involves scratch-off cards. With each purchase, customers can get a card with a black spot obscuring a message. When the spot is scratched away, most of the cards simply say, "Sorry, please try again." But during the week, 100 customers will get cards that make them eligible for a drawing for free groceries. 10 of the cards say they may be worth $200. Okay, so there are 10 that are worth 200. 20 or 10 more are worth 100. 20 might be worth 50, and the rest are worth $20. Okay, so out of 100, how many are left that are worth $20? 60 of them are worth $20. Okay, so what are we simulating? A drawing for free groceries. To register those cards, customers write their names on them, put them in a barrel at the front of the store. At the end of the week, the store manager draws cards at random, awarding the lucky customers free groceries in the amount specified on the card. The drawings continue until the store has given away more than $500 of free groceries. Does that mean they're going to stop at $500? No, they're going to find one more winner after they reach $500 if they land on that exact amount. So more than $500. Estimate what the average number of winners, didn't mean to, average number of winners each week. Okay? So in the end, we're not averaging how much they gave away, we're averaging how many people won. But we have to add it up because we're not going to stop until the amount given away is more than $500. Okay? This one's one where you got to have your calculator off to the side for you so you can add it up as you're going. So, what are we going to assign? How are we going to assign our numbers? $0 to 9 be $200. 10 to 19 be $100. Something is wrong. 20 through 59? 49. 39. Be $50. And then 40 to 99 be $20. Use a random digit table, 2 digits at a time, till total given away exceeds $500. Our response variable is the average number of winners. Okay, what? No. Yes, you could. Could we do it 1 digit at a time? Yes. We could let 0 be 200, right? We could let 1 be 100. We could let 2 and 3 be 50. And then 4 through 9 be 20. Okay. So there's an example of you kind of just going with it, the number 10. You don't think about using 1 digit at a time, and that's okay. Okay? You're going to get there. You're going to get a different answer than someone who used 1 digit at a time, but that's okay. Right? When I'm grading this, I'm going to look at yours and be like, okay, they did 1 digit at a time, and I'm going to check your single digits and how you did it. Okay? So for simplicity, because I've already written it out this way, let's just do the 2 digits. Okay, so the first one is 96, $20. So in my calculator, I'm putting in 20, 15, 100, 59, $20, 50, $20, 909. Plus 200. And so if I had more room, I would be writing the 20, 20, 100, 20 on top of here. 27 is 50. So we're at like 410, right? If you're following along. 42. 420, 97, oh, wait, no, 20, we're at 430. So now we're at 450, that was 97, right? 29, 50, so we're at 500, are we going to stop? No, we're going to do one more, 80, 20, that's the end of my trial. The average winners were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 winners. So that's trial 1. And you repeat. Doesn't say how many times, so I would do 10, especially on one like this, right? This one's long. Do we need to do one more trial? Or are we good? Kind of understand how? You can finish it up if you need to.